Okay, hi guys. Tonight we're going to look at a composition of transformations. So what happens when we take all those lovely, happy little transformations and we put them together? So that's where the word composition comes from. It just means we're going to do more than one. So composition, of reflections. So let's go ahead and get started. So let's first take a look at what a composition is. And a composition is a sequence of transformations. And sequence just means more than one, but for our purposes today, we're just going to look at one. And a sequence of transformations. So a glide reflection is the composition of a translation, which is a slide, and a reflection, which is a flip. So that's what we refer to as a glide reflection. And this particular one is a glide reflection where the translation motion is parallel to the line of reflection. Okay, so what does that mean? So let's say, for example, we took this triangle and we reflected it over this line. When we do our translation, it has to be parallel to that line of reflection. So when we translate, this image is going to translate, this image is going to translate that way. So the line of reflection and the translation are parallel. Okay, so we need to, there's a little bit of a typo on here. So on this one right here, it says reflect. The reflection over the x-axis is followed by a reflection of the line. It should say r and then y equals 4. So we are going to reflect an image over the x-axis and then over the line y equals 4, which is right about here. But we're going to look at this conjecture. Reflections over parallel lines, and again, the x-axis and the line y equals 4. Reflection over parallel lines conjecture. A composition of two reflections over two parallel lines is equivalent to a single translation. In addition, the distance from any point to its second image under the two reflections is twice the distance between the parallel lines. Alright, so let's take a look at what that means. Let's fill that in first. So, a composition of two reflections over two parallel lines is equivalent to a single translation. In addition, the distance from any point to its second image under the two reflections is twice the distance between the two parallel lines. So what we're going to do here is we're going to reflect over the x-axis, then reflect over y equals 4. So let's put y equals 4 in there. Y equals 4 is right here. There's a line. Y equals 4. So let's take a look at what that means. Make that a little bigger. So I'm going to draw down here triangle ABC. So triangle ABC, here is A, here is B, and here is C. So there is my pre-image triangle ABC. I'm going to reflect that pre-image ABC over the x-axis. So that pre-image is going to get reflected over the x right here. So let's go ahead and do that, and I'll do that in blue. So I reflect that. The pre-image and the image are equidistant from the line of reflection, all the points. So C prime is here, B prime is here, and A prime is right there. So there's my reflected image over the x-axis. Then we'll reflect that image again over the line y equals 4. So again, do the same thing. B, I'll call it a double prime, is going to end up here. Here's C, and here's A. So the conjecture says that a composition of two reflections over two parallel lines, and again our two parallel lines are the x-axis and y equals 4, is equivalent to a translation. So can we write this as a translation? We reflected it once, we reflected it twice, but this is equivalent to one translation of, in this case, 1, 2, 3, 4, 5, 6, 7, 8. And the distance from any point to its second image under the two reflections is twice the distance between the parallel lines. So let's go back and look at that again. So what that's saying is, so these two reflections I can just write as my x stays the same and my y is plus 8, even though I did two reflections. And then the distance from any point on the second image is twice the distance between the two parallel lines. So the distance between the two parallel lines is 4, and the distance between A and A prime prime is twice that, which is 8. So the distance from this image to this image is twice the distance between these two parallel lines. So if we were to write that as a rule, and again, I'm going to say it a million times, and I'll say it a million and one. Here is our pre-image, it's x, y. Reflection over two parallel lines just ends up as one translation. X stayed the same, and our y coordinates changed by plus 8. So we can call that a translation, and sometimes you'll see the letter T right there. Okay, let's take a look at the second. So a reflection over the x-axis is followed by a reflection over the y-axis. Can this be written as a single transformation? So here's our conjecture, reflections over intersecting lines conjecture. A composition of two reflections over a pair of intersecting lines, and in this case our intersecting lines are the x and y axis, is equivalent to a single rotation, and the angle of rotation is twice the acute angle between the pair of intersecting reflection, and we're missing a word here and it should say lines. So what that is saying is that if I have an image, a pre-image and an image, that the angle of rotation is twice the acute angle between the pair of intersecting reflection lines. So we only have 4 angles here and they're all right angles, so our rotation should be twice that, and twice 90 is 180. So we should end up with a rotation of 180, and it should, and again we're going counterclockwise because that's something that's understood. So let's go ahead and we're going to graph that same triangle ABC. So again, here is point A, point B, and point C. So there's triangle ABC. We're going to reflect ABC over the x-axis. So if we reflect over the x-axis, here's C prime, there's B prime, and A prime. So there's our reflection over the x-axis. Then we're going to reflect it again over the y-axis. That's what it's asking us to do in the second step, so let's go ahead and do that. So when we reflect triangle A prime, B prime, C prime, A double prime ends up here. There's B double prime, and then C double prime ends up here. So there's our new triangle. So the conjecture is saying that reflecting over intersecting lines is equivalent to a single rotation. So the conjecture is saying, so how can I get from here to here with a rotation but also with two reflections. So reflected over the x, reflected over the y. And so from triangle ABC to triangle A prime, B prime, C prime is the same as a rotation of 180 degrees. So that double reflection is the same as a rotation about the origin of 180 degrees. So if we rotate triangle ABC 180 degrees, we end up with this triangle right here, A prime, A double prime, B double prime, and C double prime, 180 degree rotation. Why 180? Because it's equal to twice this angle right here, which is 90, the acute angle between the pair of intersecting reflecting lines, even though 90 degrees isn't considered acute. Okay, so last but not least, write a single algebraic rule for the composition of transformations. We're going to translate a triangle 4 units right and 2 units up. So let's do that first. So again, we start out with our coordinates of our pre-image, which are x, y, and this is a translation. We're going to rotate that translation 4 units right, so that means x plus 4, and 2 units up, which is y plus 2. Then we're going to reflect the triangle over the line y equals x. So the reflection over the line y equals x is xy. So when we reflect over the line y equals x, what happens to our original figure is that the x and the y coordinates flip-flop. So y ends up here and x ends up here. Well, we know our y is now y plus 2 from our translation, and our x is x plus 4. So our final transformation is a y plus 2x plus 4. So it's a translation of 2 units to the right, or 4 units to the right, 2 units up, and then a reflection over the line y equals x, which made the x and the y coordinates flip-flop. Okay, now it's your turn. Multiple choice question number 1. The point 23 is rotated 90 degrees about the origin and then dilated by a scale factor of 4. What are the coordinates of the resulting image? So we rotate it 90 degrees about the origin and then dilate it with a scale factor of 4. Number 2, write a single translation that is equivalent to, and hopefully these show up on your paper. So write a single translation that is equivalent to, this should say on your paper, it should say T3, and it should say, let's do it down here. So T3 comma negative 1 and T negative 5 comma 5. So this just means a translation of the x is plus 3, so 3 to the right. So this just means a positive 3 for the x-axis, and this means a minus 1 on the y-axis, so going down. And then you're going to take this image and then do a translation of 5 to the left and 4 up. And then write that as a single transformation. So it'll be x comma y. When you combine these two right here, what do we end up with down here? That is what it's asking you to do. Be sure to record your answers in the Google form, and have a good night.